Testing, testing. Oh, mic works great. Hi, hello. Min, what's up? Welcome back. Thank you for joining the stream. Oh no, I'm see-through. I'm see-through. I didn't expect to be see-through. How would it look? Oh yeah, yep, I'm see-through. Okay, great. I like this shirt though. Now I have to change it because I'm see-through. Similar shirt. Oh, didn't realize life is so hard. I guess that works. Oh. That was fun. Okay. Hello, good morning, good other times of days are also possible. We are back with our irregularly scheduled streams. I hope we have a good day ahead of us. Oh, hello, new chatter? Hey. Taylor. Hi, hello. Do let me know how to say your name. And what do we think of the sparkles? I think they're cute. But if they're distracting or taking away from the background, I can remove them. Okay. So for today's plan, today's plan is to finish this one, like the fine-tuning a mask language model. Most likely, I like when I press run or like train the model, that will take probably a while. So like I'll have to pause there somehow and maybe move to the next thing, but I want to go at least there because I really want to finish this so that I can start the next course, which is still a HuggingFace course, but still. Yeah, and I don't think this is that far. Yeah. And I don't know what this is. Building and sharing demos. Ooh, I love Gradio. Okay. Yeah, so I don't want to be stuck. And I am looking forward to the next thing to learn. Yep. I think I paused here yesterday, or the day before yesterday, actually. Checking something on the other screen, not stream. Okay. So, we went over what a masked language model means. Well, just the task, what it is. And it's basically fill in the blank. That's it. And for us to be able to pre-train, help. We're fine-tuning it, right? Yes. So we need to pick something to fine-tune. That's the idea. And so we need to go to the HuggingFace hub to find a list of models. Here's something fun. This is, I think, from 2020 something, maybe 2022. I'm not sure. You can see like HuggingFace was still a name back then. Like I have heard of HuggingFace since 2020, I guess. And like 1,000 models, 1,600, and going now, you will be surprised at how many there are. Yeah, tenfold at least. And that's just fill mask ones, right? This is filtered by fill mask. So yeah, HuggingFace is doing great. Wow, such a high usage rate. Now it's higher. It was 58 2 days ago, and now it's 60. Okay. Yeah. So continue. Although BERT and Roberta family of models are most downloaded, we'll use a model called DistillBERT that can be trained much faster because it's smaller. Yeah. Oh, I remember talking about knowledge distillation, the teacher and student thing. Okay, so I've read this as well. All right. I think I just stopped here when I saw the code, so I'm gonna open the code that comes with the blog. It's a blog, even though, yeah, it's a tutorial page. Hello! Yes. I literally just changed my outfit during stream because what I was wearing was too green and I was see-through. The app allows you to change your clothes like as many times as you want, so yeah. Not my, it's not like yeah, it's not my ingenuity. It's built in with the app. How are you, Noir? I hope you're having a great day. And also, what is on the plate for learning today? Let me know. Yes, so knowledge distillation. And oh, I need to copy this to drive. All right, it's happening. And then we can start. I think I'm gonna, should I use it the way it is? Or like do some changes? Because if I use a different, like, let's go for, oh, this is not DistillBERT. Okay. Like, I'm just saying everything is in English. That's what I'm trying to say. The goal of life is life, survival, love, freedom, simplicity. I like that. The goal of life is life. Where is DistillBERT? BERT uncased, encased. Oh, I think I should be able to search by language. Oh, that's amazing. Congratulations. Fixing one's sleeping schedule. Like, oh my God, it gets harder and harder. I am also trying to do the same thing. Like the other day when I streamed, I was like, okay, my sleep schedule is going to be good because I stream early in the morning. And then the day after, I slept too much. Yeah, so today I'm good. We'll see about tomorrow. I have no, yep. Today you are learning about vector machine, discrete, random variable, etc. Cool. Do I remember anything about this? I have heard support vector machine way too many times. And it is not in my brain right now. Good luck. Let me know if you need anything. Otherwise, get out of here. SBM. Yeah. Okay. I'll probably be streaming for at least another 40 minutes. So see you then. I wanna filter by language. Let's see what languages do we have in our disposal. Should we go for Arabic? Good. We have some bird related. Oh, DistillBERT multilingual. I'm happy. Let's see. Bye. Let's see what languages. 100 languages. Shut up. Shut up. Oh, I don't know what language to choose. I mean, my choices are limited because the number of languages that I know are limited, but it's like a toss between Arabic and Korean. Help me. I think Arabic would be safer because I don't know, my vocabulary in Korean is hella limited. What is ROA? Wow. What the hell is ROA? I need to know. Romanian? No, that's Romanian. Okay. Turkish duysa. What else? Okay. Persian. Ooh, I like Persian. Not that I know it. Anyway, let's go for Arabic. Oh, shoot. I mean, yeah, I wasn't supposed to press it. So now, oh, I need to sign up and stuff. After running this, I need, I'm gonna hide this screen for a bit so that I can give the information there. Oh, wait, it's just name? Oh, wait, no, there's also HuggingFace login, which I'm gonna do, but I'll need to give it, the information, which I have. Yes, I do, thank God. The information. HF token, which is, HuggingFace token. Copying, pasting. Why are you showing it to me? Okay. That one, good. HuggingFace? No. And then email, which is it's not hidden. I think we're good. Unshow this. Reshow screen. Hello. And then my name is this. We should be good, right? Let's try. Kura? Okay. Work. Yeah, sure. Login successful. We did it. Now I'll have to choose please tell me how to choose a language. Come on, man. Usage. Fill mask. This is English. I don't believe that it can work with every language. That I refuse to believe, even though it's multilingual. Like I'm gonna use this and then just hope/assume that checkpoint Irman Piruhe, we only need the checkpoint name. Why is Korean mode on in my brain? Help me get out of it. Oh. So we run this and then, oh wait, I forgot, I should have said language. LAN lang. No. How big is this? Normal? That was easy to load, but like, is language? Is it? Is it not? No. I'm gonna try anyway. AR. Yeah, no. But there has to be a way to choose the language. Making me regret trying to be creative. I don't like that. Do we just go back to English? Oosh. Someday I'm gonna be less worried. Not today. Mm, okay. So, oh, mm, we're comparing distal bird to bird. Oh, wow. This multilingual one is bigger than normal bird. It's 135. But honestly, like compared to what's out there, it's not that bad. Like we've punctured billions. Like we're past millions based on my limited knowledge. Um this is a great mask. That's funny, right? I'm gonna run it. Oh, 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 so that's the text. What do we do with the text? Where's the text? That's the text. Yes. We tokenize it. We get logits and then we find the index. Can't we just like say here, do it? We definitely can, but I don't know why. Oh, we're looking at top. Fair. I see. So, top 5. Mask logits give us 5. Like if I make it top 10, we should get more. Let's see. A great deal, great success, adventure. Oh, that's cute. Great idea, great feat. Feat is not as used as like, okay, I'm guessing it's old books. Great mistake. Uh-oh, it went south real fast. Great shame, great undertaking, great achievement, great coincidence. Cool. That was fun. So, the idea is that we are fine-tuning it on a new database, and the database is IMDb, which this oh wait, I should go back to the blog. I forgot. I was just going with the code, which is fun actually. I'm guessing IMDb is an available data set here. Shoot, data sets. So if I say IMDb, yeah, we have it. Ooh, it's from Stanford. You also have it. I am curious if Turkish. See, there are like other languages. I think that's my catchphrase. Other languages available? That's my catchphrase. Okay. So I forgot to read this, so I'm gonna read this. With around 67 million parameters, the stilt bird is approximately 2 times smaller than BERT, the main model, which roughly translates into a 2-fold speed up in training. Cool. So yeah, we are testing something as humans. Oh yeah, great day does come to mind. That's true. Possibilities would be a great day. Bright, less great painting. Oh, hi. Hi, Tofu. That's so cute. Tofu the Lofu, what's up? First time chatter, welcome. You have an adorable name slash avatar. The thing that I'm looking at. Kiawa. You asked the question, are we coding? Is copying people's code and running it considered coding? If so, then yes. If not, then no. I'm running the code from this tutorial, basically. Yeah. Cool. I think coding has like let's say the past 30 years has changed its meaning. Like right now, if I take if I ask Claude Sonnet or ChatGPT to write me code and then run it, is that coding? Hell yeah, it is. You know, compared to like when you had to have, I don't know. I'm not gonna say coding in assembly because like that's way too far, but like just like basic, which I have not done. Um, must have been a different world. But I have coded in assembly, haha, for studying purposes. Um, and I think it was fun. That yeah, it wasn't the worst thing. I guess I had a good teacher. So for pre-trained models, predictions based on the corpus, obviously, which is why when I saw a great feat, I was like, dude, where did you get this from? Probably a book. Um, yes, based on statistical patterns presented in the data. Since BERT was trained on English Wikipedia and something called a book corpus, it's expected to reflect that. So if we train it on IMDb, then yeah, it will be. I'm guessing IMDb is. What are we training it on? What is inside IMDb as a data set? Like it's not movie scripts. Maybe it's movie reviews, but that would be like Rotten Tomato. Let's see. So yeah, we did this. We looked at top something, and it gave it to us. Yeah, we can see it output of the model's predictions refer to everyday terms, which perhaps is not surprising. I don't think like deal, success, adventure, and idea are pretty everyday, but undertaking less so. And also the feet one. Okay. Yeah, so our data set, we're using the large movie review data set. So it is movie review from IMDb. Got it. No, IMDb is not short for large movie review data set. It's short for Internet Movie Database, right? Yeah. Which is a corpus of movie reviews often used to for benchmarking and sentiment analysis. Oh, I see. That's cool. So by fine-tuning the Dilbert on this corpus, we expect the language model will adapt. That's help me. Why does that feel not great? Like we expect it to, not we expect it will. No? Vocabulary from the factual data of Wikipedia that was pre-trained on to more subjective. All right. Okay. Hopta. Let's see. So let's start from loading the data. Guessing if I go back to the IMDb. Okay, so people actually write reviews. That's good to know. It's English. Duh. I did see that there are other, like, see, Urdu is here, Turkish is here. Oh, Netflix. Cool. Like Netflix filtered basically, because this is 100K, this is only 6K. Posters and descriptions. That's fun. And Javanese? What's Javanese? It has to do with Java and Japan. What? Oh, I'm curious. Huh? Mandarin? Eh? What? Javanese is a language? Oh my god. Get me out of here. I'm sorry. What? Not be serious. That's so cool. Oh my god. Wow. Maybe Java started from here? Oh my god, island of Java. No. great job, Sherlock. That's so cool. I just learned something. Oh, you have to learn NLP before this HF course. Is that a question? Because not really. Or are you telling me that I have to learn it? First of all, I'll send you the link because it starts pretty well and it tells you, here you go. I think I sent you the correct link. Like if we go back. By the way, I am in Unit 7. I've gone far. This is, I think, my 40th. Oh, okay. Yes, you forgot the question mark. This is my 40th stream of like mostly taking this course. Like half of it is taking this course. And yeah. But if you go to setup, which I guess intro, it should tell you. It tells you a few things, I remember. It tells you to where is it? No? Wait, there's definitely who is this for? Definitely something like that was there, I remember. Welcome, what to expect. This course requires a good knowledge of Python. Yes, but also like if you can you see that this is loading data set, that's good enough, honestly. So like if you don't understand what's happening here, but you read the description and it tells you that you are tokenizing and looking at top whatever, which honestly it's here, you're good. Like you don't have to, even though it says it's good to take this course after taking this one, and like maybe have some knowledge of PyTorch, which I don't think I did. Like it says it's better. Even if you don't, you're good. You can just Google it. Who cares? Like if you are interested in NLP, jump to it. Yeah. Like there is no NLP police to stop you, you know? But if you're interested in another thing, you can go to that because this is very broad, NLP wise, mostly transformers and mostly things related to HuggingFace, which like maybe you don't want to use HuggingFace as a platform. I do. I do want to show you their other courses. I don't know if I've done that. This is the NLP course, and there's a deep reinforcement learning. There's, I guess, computer vision. The audio course is my next target after this NLP course. And there's ML for gaming, ML for 3D, and a course on diffusion, which is also vision. This open source AI cookbook is probably regarding how to build open source tools. I don't know. But yeah, overall they have great courses. Do like be aware that this is probably not the most updated thing, but at least it is around like 2 years ago, which is pretty updated. Like it's about transformers, that's pretty updated, right? I don't think there is anything newer than transformers. Correct me, please. Because like GPT is a transformer, everything is a I don't know if I'm guessing Cloud Sonnet is also a transformer. I'm not sure though. What was I reading? Yes, it being more subjective. Got it. So we have training and testing, which is 50-50. I am surprised. Why is it 50-50? And then we have some unsupervised data set, which I'm guessing is for validation. And it's more than the training and the testing. Cool. So we can see that the train and test splits each consist of 25,000 reviews, and then there's the unlabeled part. Yeah, so we can see, like, we can look at a few reviews. Here it's shuffling, and it got these ones. Okay, this story makes no sense. The character lacks dimensionality. Is that a correct way? Dimensionality. There we go. The best dialogue is ad-lib. Huh? About the look quality of the movie. What are you watching? And then I saw this movie at the theater. Oh. Negative, positive. Okay. Yes, these are movie reviews. If you're old enough to understand the comment about, I understand. Yeah. Probably Disney movie. Owning an what, help me? VHS. There we go. VHS. Yes, I've used the VHS. Yeah, so 0 means negative, 1 means positive, which you probably guessed. So if I run it, I should get different reviews. Let's see. I got 2 positives and 1 negative. Oh, you already tell us what it is about. It's a great movie. Plot is true to the book. Ooh. Mark Twain. Anyway. Don't get sidetracked. I already did get sidetracked. Ooh, we have video incoming. So yes, we've had a quick look. Let's learn more about processing the data. We have loaded the data set. We have looked at what's in the data set. And it's just text label. That's it. That's it. And then there's 3 splits. So there's a big whoosh when I play this video. Here it comes. Oh, I'm actually going to make it lower so that it's not that high. Let's see. It maxed out. I pulled it back and it maxed it out. Oh well. Let's go.
Let's see how we can preprocess our data for masked language modeling. As a reminder, masked language modeling is when a model needs to fill the blanks in a sentence.
Yep.
To do this, you just need text, no labels, as this is a self-supervised problem. To apply this on your own data, just make sure you have all your text covered in one column of your dataset. Before we start randomly masking things, we'll need to somehow make all those texts the same length to batch them together. The first way to make all the texts the same length is the one we use in text classification. Let's batch the short text and truncate the long ones. As we have seen when we preprocess the data for text classification, this is all done by our tokenizer with the right option for padding and truncation. This will, however, make us lose a lot of text if the examples in our dataset are very long, compared to the context length we picked. Here, all the portion in gray is lost. This is why a second way to generate a sample of text with the same length is to chunk our text in pieces of context length, instead of discarding everything after the first chunk. There will probably be a remainder of length smaller than the context size, which we can choose to keep and pad or ignore. Here is how we can apply this in practice, by just adding the return overflowing tokens option in our tokenizer call. Note how this gives us a bigger dataset. This second way of chunking is ideal if all your texts are very long, but it won't work as nicely if you have a variety of lengths in text. In this case, the best option is to concatenate all your tokenized texts in one big stream, with a special token to indicate when you pass from one document to the other, and only then split the big stream into chunks. Here is how it can be done with code, with one loop to concatenate all the text and another one to chunk it. Notice how it reduces the number of samples in our dataset here. There must have been quite a few short entries. Once this is done, the masking is the easy part. There is a data collector designed specifically for this in the Transformers library. You can use it directly in the trainer, or when converting your dataset to TensorFlow datasets, before doing keras.fit with the 2tf dataset method.
Okay. Okay. There's no chance of me finishing this blog today. I thought I could. I started late, it's my fault. Okay. Someone telling me that I say it's my fault way too much and I should, someone told me, I should, chill with that. I will try. But I mean, everything is my fault, obviously, because I'm the one in the driver's seat of my life. I mean, I know things happen, but hey, for both autoregressive and masked language modeling, a common post-processing step is to concatenate all examples and then split the whole corpus into chunks of equal size. What about the labels? Oh, we said we don't need the labels. But how do we know, how do we train? This is quite different from our usual approach. I know, right? Where we simply tokenize individual examples. Simply tokenize individual examples, yes. Why concatenate everything together? Because you said so. The reason is that individual examples might get truncated if they're too long, true, and that would result in losing information, which is useful and needed. Got it? Again, because you said so. So to get started, we'll first tokenize our corpus as usual, but without truncation true, meaning everything should be together. We'll also grab the word ID if they are available, IDs. Tokenized things will have IDs, got it. Which will be, if we're using a fast tokenizer, as we will need them later on to do the, to do whole word masking. Whole word masking, okay. We'll wrap this in a simple function, and while we're at it, we'll remove the text and label columns since we don't need them any longer. We'll only have the tokenized input. Okay. If it's fast, we have IDs. What do we do with the IDs? We put them, okay. Let's do that then. And then we say remove columns during the mapping of the tokenized function. Okay, while you do that, we shall continue. Oh, the output should look like this. We'll have the input IDs, and then we take word IDs. It normally isn't there, but we take it, right? And then the attention mask is there because tokenizer. Okay, I think I need to clear my throat, so I'm gonna mute for a sec. Done. Voice is better? Maybe. Okay. Oh, I heard that clearing your throat is not good for your throat, so yay. Since the still bird, is bird-like, bird-like. No, it's bird to like. Okay. We can see that the encoded text consists of input ID and attention mask. That's like already there. Yes. The thing that we added is the word ID. It's still running. Chill. Stop running. Now we've tokenized our movie reviews. Next step is to group them all together and split the results into chunks. Group them all together and then split it. All right, if you say so. But how big should the chunks be? Chunky? I don't know. This will ultimately be determined by, oh no, a brain, okay. By the amount of GPU memory that you have available. Okay. But a good starting point is to see that the model's maximum context size. How would we know? Like, I thought like, how long do you think a sentence is? Like, obviously it depends on, I don't know, like language but how big the model wants the input to be, basically. So tokenizer model length, if it's bigger than that, then it won't accept it. So value is derived from the config file with the checkpoint. Got it. So other transformers like Big Bird and Longformer, that's cute. Big Bird and Longformer have longer context. Okay. So in order to run our experiment in Colab, we should make it even smaller, 128. Note that using a small chunk size can be detrimental in real world scenarios. You should use a size that corresponds to the use case you will apply your model to. Like, for example, if it's a tweet, then you already know what your context is, depending on the year. And I think Twitter APIs don't work anymore, but like you get the gist. Like if it's a YouTube comment, you assume that it's not at least like a blog, you know? And if it's a blog, then you assume that it's big. And give me something that's like small. Reddit comments? No. What's something like just short answer and short word answers? I don't think such a thing exists on the internet. But like maybe if it's a game. Oh, Twitch comments are pretty short most of the time. Okay, that was good. Yay! I forgot I'm streaming. Okay. So I'm lying. How can one forget they're streaming? Anyway, fun part. What's the fun part? Wait, before we go to the fun part. So that's finished. We have our input IDs, attention mask, and the added word ID. For all of our 25K here, 25K here, train test, and the unsupervised 50K. Like the total, the length is 512. Can you see it? Yes, you can. Maybe you can. Sure. And then we update the chunk size. Here we go. And what is the fun part again? Show how the concatenation works. We'll take a few reviews from our tokenized training set and print out the number of tokens per review. All right. Oh, that's actually fun. We want to see how many. So this is our data set, tokenized data set, and we're taking a sample. Let's take 5 and 10. I took 10. And then we're just looping through it and printing it. So we have 300, 100, 400, 100, 300, 700. Someone had some, like, a lot to say. And then average is about like 300. 50, let's say. Yeah. What else? What else is out there? We can then concatenate to our like chunk size, right? With a simple dictionary comprehension as follows. Oh, we concatenate everything together, but we have to then cut it into our chunk sizes. All right, well, we do that. I want to know. Oh God. Oh, okay. There. I'm gonna pause here, okay? Because my brain is like overheating. Help. Okay. So we concatenate our list of samples. And let's do that. Mine is 10. I didn't realize. Yeah, that's 300. That's a lot. And then total length checks out. Sure. Wait. I was right. Average is 300. I mean, it's 3,000, but if you divide it by 10, it's not even 350, it's 300. Yay, I'm smart. I can do basic calculations sometimes. So we split them into chunks. To do so, we iterate over the features in concatenated examples and use the list comprehension to create slices of each feature. The result is a dictionary of chunk for each feature. Cool. Like, I really don't understand what's going on here. It just works, so we just run it. But let's try to understand what's going on. That's a loop. And then we have a range. And then for that loop in that range, I don't like inline loops. I really don't. My brain understands better when it's like all spelled out. What's T? T. K is the whole thing. T is concatenated examples dot items. We're just looping through it. No, we have a chunk size, which is the end of the range, right? Help. Oh, we're going through indexes. From I. Now I'm mad at myself. So from I to I plus chunk size, meaning if it's the 0th, we're taking 0 to 128. If it's 1, we're taking 1 to 128. We're doing that like repeatedly. Or are we going chunk size by chunk size? Basically, this is the how far we go. Got it. So if it's 0, it's 0 to 128. And when it comes to 1, it's not really 1, it's 129. Cool. I sort of understand it. Hi. Hello. Your name is, I'm not gonna say your name, but also hello, hi, welcome. It's supposed to be a meme, I get it, but I do not want to say that. As you can see, also thanks. Thank you. In this example, the last chunk. Oh, wait, hold up. How many chunks, like this was the previous one. Mine is 3,000. It should be chunked into at least 9 chunks. Oh, why did I think, huh? My math didn't math out this time. Sorry. How many is this? More than 9, that's for sure, right? Wow. I was watching this tutorial the other day, and what is NLP? Good question. I shall answer you. Should I answer you like in a serious environment? Environment changed, and now I'm serious. So ML is machine learning, and NLP is natural language processing. Programming languages, I'm guessing you're asking, is it a programming language? Not really, but you can use programming languages to do ML or NLP. And like, you know what AI is generally? Machine learning is more like the algorithmic, like real side of it, where you try to do AI, and NLP is one of the, not an application, not a task, but like a subfield that is in collaboration with human languages. So whenever you are using Siri, or you're using Google Translate, or you're using something that even new way to programming subjective thing, I wouldn't say that. It's, I mean, maybe if you want, but I wouldn't say it's a new way of programming, because, and I forgot to remove that. Okay. Because like NLP, text to speech, speech to text, all of this is NLP. Like audio is also NLP. It's not just about programming. And these are applications, by the way. Yeah, this is basically fill in the blank, the application that I'm currently not working on, but I'm learning. I hope that answered some of your questions. And if I was using too many big words, let me know, so that I use words that are, it's okay if you don't have a background in computer science. You don't need to know all of that stuff. If I was using like words that are too, like, I know when I say NLP, people may assume it's neurolinguistics, something. It's not. It's to do with computer science. Yes. And yeah, I was about to say a joke, which I'm going to repeat it. I was watching Crash Course Linguistics. Oh, of course, not familiar with those things, because I'm mainly, oh, so you do have a background in computer science. Cybersecurity engineer. Cool. Yeah, but you know what they are. Cool. Yeah, my background, doing AI is, my background is not in that, so that's why I want to learn more. So if you're interested in that field, hop on the wagon. If not, I hope you learn something fun. Even if it's, I'm definitely sure that AI in quotes, infiltrate your field as well. Sorry about that. Not my fault. Definitely not my fault. But yeah, it's everywhere. The funding is there right now, so people want to say our app has AI. Yes. So yeah, in the crash course linguistics, there was a part explaining a meme and saying, look at all those ducks. It's at least 10 when it's like 50 or more. So yeah, when I said 10, that's at least 10, and that's correct. Mathematically speaking. I have background in machine learning. Ooh, deep learning. Oh, that's so cool. Oh, that's cool. Which means, in a world where everything is changing and new things are appearing, we have like a tiny bit of relevance, depending on where you are. Like in my country, I would like to think that I have, based on my the information I have, I'd like to think that I have relevance. But like if I was in Silicon Valley, I'd probably have zero relevance, So context matters. As you can see, chunks get smaller. It has to anyway. We have drop the last chunk if it's smaller, or pad it if it's smaller. I think I'd rather pad it and not drop it, because context, right? We'll take the first approach. Drop it? That's mean. Shouldn't they? Let's wrap the above logic in a function. This thing, grouping the texts. Oh, we already did. Okay. And then apply it to our data set. This is the function. This is the logic. All right. Function. And then apply. Batching true. Where did we drop it? Split. Drop. This is the drop. Mean. Okay. Note that the last stop in group texts, in the last stop, we create a new label. Okay. We dropped the label column, so now we want it back. A copy of input IDs. We'll see shortly, because in mass language model, oh, wow, what's wrong with my brain? Obviously, we don't need the label. We're doing mass language model and not sentiment analysis. I mean, the other label. I hate loop function. That's why I chose to go networking. There are no loop functions in networking. Sign me up. I got a passing grade. Like if I had one more mistake, I would have a failing grade in network during like my bachelor's. So I don't think I can join you, but I don't hate loop functions. I just dislike the way that it's written here. Like when it's spelled out, I feel more comfortable. Like I want the programming language or the code that I write to be something that I understand. And recently writing code with oh, my brain obviously sucks. Like it's not even a question. But point is to keep trying, right? I mean, you're trying on the networking side, so that's cool. But yeah, I'm very sure that a good chunk of programmers have imposter syndrome. At least I do. Yeah, but like I say, using like language, help me, chatbots like ChatGPT and Cloud Sonnet to write code, like it's probably not the best thing, but it's also not the worst thing, because even if you don't understand it, you can tell it to explain it to you. Yeah, I do that. Like I write code using Cloud Sonnet. I've done it like at least the past month. Yep. And I don't know why, but Cloud Sonnet is a she in my mind, and she is doing a great job. Yeah. She's less social than ChatGPT in my brain, because that's how I use it. Her. Yeah. She's doing a great job. She can write loops for days. So our label is a copy of the input ID. Why? What are we doing with the input ID? As we'll see shortly, it's because mass language modeling, the objective is to randomly predict randomly masked tokens in the input batch, and creating a labels column. We provide the ground truth. Okay. So we need to have two versions. Yeah. I use ChatGPT and Cloud Sonnet and stuff like that. Language models, LLMs. Because I mean, if you can't beat them, join them also. In a world where everybody is using a rocket, why use a tricycle or a bicycle? Why did I go to tricycle? You know what I mean. Yeah, most of my projects using ChatGPT. Yeah. Oh, so you are a student. Cool. That's cool. Yeah. If you're a student, I suggest for one of your projects, involve somehow, like if you, I'm not saying do anything from scratch, don't. But like if you Google security stuff, you said cybersecurity, and and like AI, ML, and like go to Kaggle maybe, I'm very sure there are like data sets about. I don't think Hugging Face would be the best place, which is where I'm on right now. I think Kaggle would be a cool place to see if there's cybersecurity related stuff. Can I look for it? Uh-oh, I am distracted. Kaggle, cyber, security. Oh, of course there are. Of course. But like, see, there's a cybersecurity attack data set. Cybersecurity. Let's look at it. It's not that much though. It says 25. Oh, I thought it says 25 records, but it's 40,000 records. Varied metrics. Is this like, updated 11 days ago? That's so cool. This is mostly just, like analyzing, but still, it's pretty cool. Hello, Tech AI, what's up? Yeah, so do that. I think that would be fun. Even if you don't make anything out of it, it's still fun to have the information. How are you? Yes. I can't get much out of a hello, so I'll just say hello back. Okay. Yes, ground truth. Got it. And then we applied it, which we did after doing the copying thing. And that's, huh? Oh, the size of the data set has changed because of the chunking. Wow. Look at that. Why is this bigger? They were literally the same size. And then we can look at something. Let's look at number 100. Do we have any splitters? We do not have any splitters. Let's go for 101. No split. Anyway, the other ones had split because they were like middle of. Let's go back to number 1. Oh, not here as well. Cool. Anyway. So, what's next? We can see the grouping and chunking has produced more examples than the original 25K for training and splitting. That's because we have examples involving contiguous tokens that span across multiple examples from the original corpus. You can see this explicitly by looking at, yeah, we saw this. It's not here, but it should be. Yeah, okay. Two overlapping. Oh, there we go. See, now I see the overlap. I don't think there's anything to do with, I don't think it has anything to do with losing information, the chunking and stuff, but hey. Like, this is about one movie. This could be about a different movie, so. Anyway, as expected from our group text function above, this looks identical to the decoded IDs. But then how? Oh yeah, labels and IDs. This is input IDs. And if we go and check labels, it should be the same. Let's do that. Labels, copy and paste, because ground truth, exact same. So how can the model learn anything? We need to mask random tokens in random positions. To do that, let's see how we can do this on the fly. Wow. During the fine-tuning using a special data collator? Not spatial, special. Got it. Oh, hi. Hello from Bangladesh. Hi. That's cool. Should be somewhere around noon, based on my knowledge of time zones. So I'm actually gonna pause here because my brain cannot take anymore. And I think we're halfway. We're here. No? Are we? We're here? No. Where are we? Fine tuning with trainer API. We are right here. Got it. Exactly in the middle. I'm gonna actually watch this just for a bit. Like maybe the next 15 to 20 minutes. I think I have that. So let's do a refresh. And play this. Let's see how much time we will need. 5. Okay. In my brain, we will try to reach here. But if we don't, that's cool. Let's go.
The reason why it is important to do this is several-fold.
Right. Voice is lower than mine. What do we do? I don't know. Let's just watch. I think oh, you can't see it. It's too high. Now you can see it. The subtitle should help, and it is at the top, so because sometimes there's text here. I think I don't mind it being here.
But the most intuitive way to think about it is if we think about the things that TF-IDF does, TF-IDF is giving a very high weight to contentful words and rare words. And we're not guaranteed that any random embedding that we get is going to do that. So for example, if we just take the average word embeddings of every word in a sequence, it's going to give the same weight to all of the words in the output. And in fact, common words tend to have slightly higher norms than infrequent words. And so that would actually upweight common words, which is kind of exactly the opposite thing we want. So how do we learn retrieval-oriented embeddings? The normal way we do this is we select positive and negative documents and then train using a contrastive loss. And so an example of this is...
I have no idea what's this thing.
We have a query, and then we have negative documents for that query, and we have positive documents for that query. And we formulate a hinge loss or maybe some sort of probabilistic loss similar to the hinge loss, and do fine-tuning of the embeddings. So if you have gold standard positive documents, then this is relatively easy to train because you just need the positive documents, and then you can get negative documents in a number of ways. One common
would be taking away the positive, and what's left is negative?
Common way of getting negative documents is you just form a batch of data. And given that batch of data, you take all of the other documents in the batch, all of the documents in the batch that are positive for some other query, and you use those as negative documents. So you sample 32 query document pairs, you use the aligned ones as positive documents, and then use the 31 other ones as negative documents. And this is both effective and efficient because you can kind of learn from the query document pairs all at the same time in an efficient implementation. However, this is not enough in many cases because that will end up having lots of very kind of obviously wrong documents because, you know, they're documents that are relevant for a completely different query, and it's kind of easy.
I am from somewhere in the Middle East. Yeah. Sorry, my accent does not help. Yeah, I'm not from Europe nor the US. Yeah.
Easy to distinguish between those. You can just look at superficial word overlap. So another common thing to do when you're training these models is to get hard negatives. So hard negatives are basically negative examples that look plausible but are actually wrong.
Huh.
And
How?
so here, this famous method called DPR it basically learns the encoders based on both.
Does that mean if you know something negative? Wait, help. I had an idea, now I'm losing it. Like if our supporter thing, like the RAG, the retrieval stuff, knows all the negatives, then it helps the model get a better answer on analysis of like positive and negative.
In batch negatives, like I mentioned before, and hard negatives that were created by looking up documents with VM25. And so the ones that were looked up by VM25, kind of look very similar superficially, but they might have, subtle errors in them for why they're inappropriate. There's also methods to learn these retrievers based on kind of not supervised data. So one major bottleneck, if you're taking the positive documents from human annotations of whether something is correct or not, or human click-through logs, or other things like this, is that you need that data in order to start training a model. So Contriever is another method that uses two random spans within a document is a positive pair, and random spans from across documents is negative pairs. And so this can be used for, very, very large scale initial pre-training of the models. And then after you've done that large scale initial pre-training, you can then go in and fine tune it on, actually annotated data to improve it further.
Okay.
Okay, so we've talked about training these dense product models, these models that look at dense embedding overlap for nearest neighbors. But the problem is, in order to calculate this, you would need to calculate it over a very, very large document base. And just taking a product between the query and all of the other.
Thanks. Yeah, I watch a lot of movies and stuff. Well, I watched a lot of movies and stuff. Now I'm more obsessed with the Korean language, so yeah, going where my obsession takes me. Yeah.
Documents in the document base is extremely costly. And so in order to fix this, there are methods for approximate nearest neighbor search. And these are methods that allow you to retrieve embeddings that have the maximum inner product between them in sublinear time. And because you're doing the maximum inner product, this is also often called maximum inner product search, or MIPS. So I'm going to
maximum inner product search, MIPS.
Introduce on a very high level two common methods to do this.
He's talking very slowly. I'm gonna fall asleep. Help.
The first one is locality sensitive hashing, or this can also be called kind of inverted index as well.
Inverted
and
index.
What you do is you make partitions in continuous space, and then you use it like an inverted index. So let's say we have a whole bunch of embeddings. I demonstrated two-dimensional embeddings here, but in reality, this would be, as large as your word embedding, your query and document embedding space. So this would be, 512 or 1024 or something like that. And what you do is you define a whole bunch of planes.
Trying to stay awake. Honestly, I'm thinking changing what I'm watching right now, because my goal was to end the stream and then go watch the Crash Course Linguistics course, but I'm like, why? I can do that on stream. Who cares? I think. But I will let him finish this one, because even though I don't understand, I need to come back to something that's, somewhere not in the middle of a sentence.
That separate these points into two spaces. So if this is our first plane, all of the points above the plane will get a 1 for this partition, and all of the points below the plane will get a 0 for this partition.
Okay.
And we do it similarly. We create a whole bunch of them. And then based on this, we can now assign sparse vectors depending on each of these planes. So we have, for example, the top one, 1, 0, 0, because it's on the right side of the
That's really interesting. I don't think I've seen this. What I've seen has mostly been like division.
blue plane and the wrong side of the red and the green planes.
Sure. Oh, you're actually being kind. Thank you. I appreciate that. Tell me, what advice do you want and how I can help? I don't think my advice is good, but if my experience is somewhat similar, I can do my best.
And then for the top right, we have 1, 0, 1 because it's on the right side of the blue and the green planes and the wrong side of the red plane. And so
that makes sense. Like, this makes sense, but I don't know how it should be used.
Based on this, now we have a sparse vector, and we already know what to do with the sparse vector, right? We look it up in an inverted index, just like we did for a sparse, sparse lookup table. So that's one method. Another method uses a graph-based search, and the basic idea behind this is that we create hubs.
Okay.
And these hubs are kind of a small number of points that are close to other points in the space. And so we create some hubs and then we search from there. So if we have a similar looking
grouping,
set of points in the space, we find these hubs.
I feel like I've seen this style of grouping. Don't know what it's called, but I'm sure I've seen it somewhere.
Hubs, which are something like cluster centroids. And then based
clusters, duh.
on the cluster centroids, we then rule down, or we greatly reduce the number of points that we need to be looking at. And then we search through only those points in a more kind of extensive manner. And you can even turn this into a tree where you have hubs and then you have
branches,
kind of mini hubs, and then you have all the points. So this allows you to do a kind of tree-based or graph-based search.
Cool.
So obviously, unless you're really excited about these algorithms, this is something that you probably don't want to be implementing yourself.
Okay.
And the good news is there's lots of very good libraries that help you do this. In fact, there are so many libraries, it's hard to manage them. But some libraries that people very commonly use, I think Face, F-A-I-S-S, is a widely used one created by Fair in Meta. And ChromaDB is a separate one that is kind of an AI native embedding search database. So both of those are good options.
All right, we pause here. We go to a comment, which says, I completed my bachelor's in accounting and information systems in 20. Oh, you completed it. That's cool. You're learning data science in stage of an ML. And oh, you are taking a course. Wow. You'll complete it within 1.5 months. Wow. And what should you start? NLP for deep learning or ML ops? That's a really tough question because like it depends on where you want to go. But also, serious question is, are you job hunting or do you want to do research? Like, do you want to go academia or do you want to go work somewhere? Even when it comes to work, like where do you want to work? That also matters. Because if you want to do a master's and you want to learn before you start your master's, that's pretty cool. But if you want to work somewhere and they need you to have ML related projects, then maybe you should shoot for that. I think you should mostly like shoot for a goal before you just learn stuff that's out there, because there's way too much to learn. I would know. Yeah. So depending on what you want to learn, it really, really, really like changes. So yeah. So I am gonna, you want to work in marketing or supply chain domains? I have zero information about that, but I'm sure there are applications of ML within marketing and supply chain. My question is, like based on, let's say you have a dream place you want to work for. Do you know what tools they use? Do you know how they're integrating AI? Do you know if they are integrating AI? Can you like, I don't know, like how can you turn your learning into the job? Screen is different. Later you'll enter in NLP related jobs. Okay. So you are interested in natural language processing. So you have to do them in parallel then. You can't just give it all to the learning. You have to do both. So just, yeah. You know what? Whatever job you're interested in, like try for that. Data analyst is a good, it's a good paying job, but if one is not interested in, then it is not, easy to maintain if you're not interested in the thing. Even if you're interested in, it's still not easy, so yeah. If you're interested in natural language processing, then there are really good courses out there. You have a background in information, so I think your CS is pretty solid. So I started with the Jeremy Howard Fast AI NLP for, is it NLP for practitioners? Something close to that. The link was here, so I'm just going to use that one. Oh, that's deep learning. Uh-oh. Well, Fast AI has many courses. They're not very well. Oh no, Fast AI is mostly like general ML. General ML. You are taking general ML courses, so you want to focus on NLP. I mean, this Hugging Face is pretty cool. I like it because it's very NLP focused. I think I already shared the link. What else? Stanford has cool NLP related courses, but like this CMU Advanced NLP lecture series is not for the weak of heart. Like it's not easy. By the way, how much linguistics info you have? Because like I want to make my linguistics, like knowledge base better, which is why I actually already started this. Like I've seen 10 videos out of 17, but I sort of want to watch it on stream for reasons that will later be obvious. I mean, the reason is just that I like Crash Course, that's it. And I think that I shouldn't keep it for myself. Yeah, that's the main reason. Yeah, this is just an intro.
I'm Taylor Benke, and welcome to Crash Course Linguistics. Language is everywhere. It's what we use to order a pizza, talk on our phones, tell jokes, and make sense of the world around us. We've used language to learn about every other subject on Crash Course, and now it's time to learn linguistics, how language itself works. Over the next 16 episodes, we'll look at the structure of language, from the smallest building blocks of sounds and hand shapes, to the structure of words and meanings, to how words go together to make sentences and conversations. Along the way, we'll also look at the relationship between language and our identity, the brain, and even computers. We'll learn about writing, language acquisition, and the diversity of human languages. There are actually over 7,000 identified languages in the world today. That includes thousands of spoken languages and hundreds of sign languages. They can be found in small communities or span across multiple countries. They can be written or unwritten, and they can be learned through family, formal schooling, or broader social networks. Each one is a living experiment into how humans communicate. Throughout this series, we'll be sharing examples from widely known languages as well as some you may not have encountered before. But we won't be learning one language in particular. Instead, we'll be looking at similarities and differences across many languages, learning how to think like a linguist about the languages we encounter in our everyday lives.
I want to do my master's in 2025. That's so cool. Advice about choosing a master's subject. Meaning research stuff, right? Because I'm guessing you'll do your master's in computer related. Okay, I have things to talk about in that part because I worried about my master's topic quite a bit. I have a video about my master's actually. If you are interested, you can watch it. It's less about how to take it, it's more about what I took. I think I really want to make a video about my master's experience, more just talking about it and less about this is the subject I took. Regarding like when I went to the master's degree, like before I started, what I did was, choosing a university, because maybe it's the university that you did your bachelor's, maybe it's a different university, and first thing you want to do is check out the professors, lecturers, the people who teach there, and you need to see what they're experienced in. So like I was interested in natural language processing generally. I didn't know what I wanted to do within that, but at least I knew that I was interested in natural language processing, and I checked the background and like not really research, but just background of the lecturers to see if there's anyone who could be your potential supervisor so that you can start the conversation early with them. So yeah, I actually emailed a few of the lecturers before even being accepted. Definitely before being accepted. And one of them got back to me, and that person became my supervisor. So, I mean, it's not always that lucky, but it's possible. And like just before, like even when you are a student, based on my information, you're not forced to choose a subject, a topic for your thesis in the first year. So if it's a 1-year master's, then I'm guessing it's different. But if it's a 2-year master's, then you should have the choice to just be a student for a bit. And what you can do is, if you do not have anything, if you have zero idea, what you can do is go to each teacher, especially the ones that you like, because just having the same vibe, the same style of thinking. Like if the teacher is too tough for you, then I suggest you don't go to them. If the teacher is too loose, maybe they wouldn't be the greatest supervisor. So you can go to them. And actually, great question. Thank you for directing my conversation. If I get chance, then I start research on scientific ML on accounting, fraud, and audit. That's amazing. Another thing you could do is, so there are 2 things you could do. If you have nothing, if you have zero idea, you can go and tell them tell the lecturer, talk to them saying what is their research interest and what do they normally do research on and how can you contribute to that. Or like based on your idea, of course, wait, I'm not done talking. Based on your idea of like saying, you have an idea of what to do, you go to the teacher who is like, you can go to 2 different types of teachers, the one that work on the thing that's close to your idea, or the ones that you vibe with, and say, this is my idea, can I work with you? Some of them may say no, some of them may direct you to other people, which is also a good thing. So that's my 2 cents. I hope that was useful. You're very, very, very welcome. Yep. I'm gonna go back to my video. Let me know if you have any more questions. I am willing to yap.
We're excited to produce a series on linguistics because it's super relevant to lots of fields, including speech recognition and natural language processing, speech pathology,
Did you look at
lexicography,
that?
and communication.
Natural language processing, because language, duh. Can I make this smaller? It's too big.
It's also useful if you're teaching or learning languages, not to mention for journalists, poets, translators, interpreters, and other people who work with language.
Someone's wearing hijab. I love seeing people wear hijab in, representation related stuff.
And if that sounds like basically everyone, it kind of is. More generally, understanding linguistics helps us understand how our own minds and bodies work, and the hidden patterns in our interactions with other humans. It's also really fun. Regardless of what part of language we're analyzing or which language or languages are our focus, a linguist is interested in language as it's actually used. Linguistics is not about trying to establish and enforce one variety of language as better than another. After all, if we were studying rabbits, we wouldn't go around telling some rabbits that their hopping style is better than others. But this increased understanding of language does come with an ethical responsibility to be kind and compassionate with it. Before we get into it all, let me introduce myself. My name is Taylor Benke, and I'm a writer, video maker, and digital organizer. I studied linguistics in college alongside writing and Spanish. Ever since, I've been fascinated by how language works and how it shapes our identities. I think a lot about the power of language as a tool for communication, both in my work with digital communities and on my YouTube channel, It's Radish Time. I'm excited to keep learning about linguistics with you. See you in the first episode.
Oh wow, something happened.
A_Itsky just
Hello,
changed
I'm
glasses.
Taylor.
We should do that? Alright. Who art thou? Aitski. Let's change glasses. Let's change glasses. I don't think I can show you the list of glasses. Should I try? Because if I do, I might break something. Before I answer your question, I'm gonna try to change my glasses. Let me know. Do you want a meme glass? White glass? Tell me. I can't show you the list. I'm so sad. Can I make it longer? I can't. I'm sorry. Do you want a 90s style glass? Do you want a pink glass? Give me a glass. My pick. Aww, your avatar is adorable. I'm feeling Mimi right now. Let's go for the meme one. Ta-da! We did it. We changed glasses. By the way, I put a soundboard style thing somewhere. I don't know if you can use it. Have at it if you have the energy. I like Twitch because you can interact better with your audience. Question. Oh, we are done with this one. Right. Did I just restart it? There. The end. It ended. Your last question, you want to ask how to improve English based on my journey. So literally like 2 nights ago, I was telling my sister I'm happy that I learned English as a child because learning it when you're older is not as easy. What I can say is what I'm using for my current language learning journey, which is Korean. I'm learning Korean right now. And I like K-pop, so listening to songs, but not only listening to songs, but like trying to memorize the song so that you can repeat it exactly the way the singer is singing it, is one way to improve your pronunciation. I'm pronunciation as well as like maybe some vocab, but not really that well. Watching TV shows and movies of things that you like, it shouldn't be boring. Like if you don't like horror, don't watch horror, but watch stuff that you like and then try to repeat what the actors are saying. It helps with just because I don't know why accents are important to me. Just trying to sound native is important to me, so I do that. Yeah, I was literally watching a K-drama like 2 hours ago. 6 in the morning. Yep. Not healthy, but hey, it helps me wake up. It really does. So yeah, that's my advice. Not great, but also it's fun. Like, I'm not gonna go and tell you go read a huge book. I like reading books, but it's not as fun, honestly. If you like books, I do suggest listening to audiobooks. That helps with your vocab. But if you don't, then don't. Like if you like Harry Potter, or if you like, what else is out there? I mean, there are a lot of stuff out there, but some of them have not been turned into movies. Like you can do the book and then the movie, and then like that could take like at least a month, which would be fun. Yeah. Okie dokie. So even though I only watched the intro, I don't really have the time to go to first video, which is like 10 minutes. Not that long, but I don't want to for now. I shall continue tomorrow, I think. No? Wait. Can I stream tomorrow? I do not have any problems with my R's because I am like that one. I'm good. I can do it. How strong do you want me to make it? I'm good. It's already a thing in my language, so that's why. Yeah. English is not my first language, obviously. Nor is Arabic, but Arabic does have some strong R's. Why can't I think of an example? Help. Yeah. Yeah, I don't know why I care so much about sounding good when speaking a language. Like my Korean like vocab is zilch. My pronunciation is pretty good. And that's good for tricking a foreigner and then getting into trouble. I mean tricking the person who speaks the language. I wanted to do something, which was check my schedule. Yes. That's what I wanted to do. Because I don't know if I can stream tomorrow. Answer is, she can stream tomorrow. I can stream tomorrow. Then, thank you. 감사합니다, which is thank you in Korean, and shukran is thank you in Arabic. Yay! I mean, I know thank you in a lot of languages. That does not mean I know the language. So yeah, tomorrow shall be us at least doing this part and not running away from it. And then I really want to do crash course linguistics, at least like 1 to 2 videos, because it's not that long and it is really fun and informative. So that'll be fun. And that one is getting harder and harder. So wish me luck on that. Yeah, but like fun things to come. Yeah. One thing I love about this lecturer, Graham Neubig, is that he cares about multilingual NLP, because I don't know what percentage of NLP is in English. I don't know. I think multilingual is going somewhere, but it's not gone far. Anyway, I mean, it is going places. My phone is at 6%. It can turn off anytime it want, and then my face will be gone. So I need to go. Thank you so much for the people who, oh my God, oh my God. I need to go. My phone died. Bye. I'm sorry. Goodbye. Thank you. Okay. Thank you. You're kind. Yeah. I'm gonna end the stream. Thank you for the lovely people who talked to me today. See you next time if you are available. If not, no worries. Do what's good for you. Awesome. Oh my God, hi. I need to go. I'm not even here. I'm a ghost. Thank you. And goodbye. Yeah. Thank you so much. See you next time. Bye.